Okay, today is the last lesson where we're going to be learning a method to solve quadratic equations. We're going to develop and apply something called a quadratic formula today to solve quadratic equations. We're going to skip the getting started and construct your understanding, and we're going to go straight into learning about where this quadratic formula comes from. I'm not going to go too much into detail because we're going to do this a little bit in class, but I would just want to show you like a little bit about where it comes from. So let's say you start with an equation like we have been, where you're trying to solve this. And let's say you're trying to solve it using completing the squares. But let's say we don't actually fill in what numbers are here for A, B, and C. We're just going to leave them as A, B, and C. So if you recall, the first thing you want to do is divide by or multiply the equation by something that's going to get rid of the A and make that leading coefficient a 1. So you would choose multiply everything by 1 over A, and you would get an equation that looks like this. Then you move the constant to the right-hand side, so it looks like this. And then you use that little completing the squares formula. So you take half of that middle number and you square it. So this would be the number that you would add to both sides to complete the square. And it looks very complicated now, but don't worry about that. This is just where it's coming from. I don't need you to like rederive this formula for us. I'm just showing you kind of the basics of how they got it. And then you factor that equation. So it would factor to this. You take the square root of both sides. So you would get this. Don't forget about that plus or minus. You simplify that a little bit, and then you isolate the x, and you end up with something that looks like this. So this is going to be called our quadratic formula. And it's basically like a shortcut of completing the square. And A, B, and C are the just the numbers that you see in the original equation when it's set to 0. So the A, the B, and the C are these numbers you see in this little formula. And we're going to be using this now. This will be given to you. You don't have to memorize it, although when you use it, like it's burned into my memory because I've used it so much. So eventually, as you use it a lot, you'll probably start to memorize it, but you will be given it. You don't have to memorize it. So again, here is the quadratic formula. So it's negative b plus or minus square root of b squared minus 4ac all over 2a. And I'm going to show you how to use it today. So instead of factoring or completing the square from scratch, we're just going to go straight into using this little shortcut formula, which is basically like a shortcut version of completing the square. You just don't have to do all the work. Okay, so let's go ahead and try and apply it. Now we're going to see something different with some of the equations today. For all of the equations we've seen in the past, they've always had solutions. Some of the equations today are not going to have solutions. So not every quadratic equation has solutions. And we're going to see next lesson which types do and which types don't. But for now, yeah, just know that like some equations today, when we try and use this quadratic equation, some will have real solutions and some will not. Okay. So let's look at this. We have x squared plus 2x plus 7 equals 0. So the coefficients in front of each term will tell us what our A, B, and C here are. So our A is going to be 1, our B is going to be 2, and our C is going to be 7. So we're going to use the formula. So I'm just going to write it from memory because I just remember it, but you can flip back to that last page and see what it is. It's negative b plus or minus square root b squared minus 4ac all over 2a. So wherever there's a b, an a, or a c, we're going to use these values. Okay, so let's go ahead and do that. And it's just a plug and chug here. So I'll have negative 2 plus or minus 2 squared minus 4 times 1 times 7 all over 2 times 1. Okay, so wherever there was a letter, I just put whatever letter, whatever value that letter was equal to. Okay, and then we just simply simplify and we're finished. So it really is a shortcut. Okay, so we're going to do what's under the square root first. Here we'll have 4 minus 28. And then on the denominator here, 2 times 1 is just 2. So we'll have -2 plus negative, so 4 minus 28 would be -24. Uh-oh, you can't have a square root of a negative number. So this is an equation that won't have any answers, actually. There's no solutions. There's no number I could plug in for x here and make this equal to 0. So this has, I'll put square root of -24 is not a real number. So we say this equation has no real solutions, where the way the book writes it is this equation has no real roots. Root is another word for solution. So it has no real roots, no answers. There's no possible value for x here. That'll make this equation true. Let's try B, because B will have an answer. I'll have 2 answers, actually. So I'm going to write it down here. And I'm just going to copy it from my book. So it's x squared minus 2x minus 7 equals 0. And so remember, the coefficients are your a, b, and c. So in this case, a equals 1, b equals -2, and c equals -7. It's -b plus or minus square root of b squared minus 4ac all over 2a. So I'm going to plug my b, my a, and my c into those spots in the equation. -2 is +2. So what -b means is it like changes the sign of b. So instead of -2, it'll be +2 there in front. -2 squared would be 4. 4 times 1 times -7 all over 2 times 1. So I just plugged in the numbers into the equation, and then we start simplifying. So we're going to make that middle term, or sorry, that square root term, we'll actually evaluate it. This time it's going to be positive, 4 plus 28. So it'll be square root of 32 all over 2. And we do want to simplify this down if we can. So we have to remember back to the previous chapter when we learned how to simplify square roots and make them into mixed square roots. So 32 can be written as 16 and 2, and 16 can be evaluated, square root of 16 is 4. And since every term has a 2 here, this is a fraction, so when every term can be divided by something, you can cancel it out. So we can divide every single term by 2 and cancel those all out. So we have 1 plus or minus 2 root 2. Those are my 2 values for x. So it's either x can be 1 plus root 2, or it could be 1 minus 2 root 2. You can keep it in this form. It's not necessarily wrong, but it's not going to match the answer key. So it is good practice to simplify your answer all the way down fully, because then you're going to match the answer key, and it's going to look a little bit simpler in the end as well. So if you can write your radical as a mixed radical, and you can cancel some stuff out from every single term in the fraction, then you want to do that. Okay, so let's practice a couple more times. So for this one, I'm going to do A, and then I'll start you off on B. So A looks like this, 2x plus 1, x minus 1 equals 5. So in order to apply the quadratic equation, we need to get it looking like the quadratic equation format. Need this to look like ax squared plus bx plus c equals 0. If it doesn't look like that, I don't know what the a, the b, and the c are. So in this case here, if it looks like this and I want to apply the quadratic equation, I need to FOIL it out and move everything over to the left-hand side. So this would be 2x squared minus 2x plus 1x minus 1 equals 5x. And then I'm just going to move the 5x to the other side and collect all those like terms there. So I'd have 2x squared minus 7 plus 1, so negative 6x minus 1 equals 0. Okay, so now I can tell, now that it's in this format, I can tell what my A, my B, and my C are. So A equals 2, B equals -6, and C equals -1. Okay, so now I'm ready to apply my quadratic formula. So it's -b plus or minus square root of b squared minus 4ac all over 2a. So it's going to be -6, so positive 6 plus or minus 36 minus 4 times 2 times -1 all over 2 times 2. So this would be 6 plus or minus, so this would be 36 plus 8. So that would be 36 plus 8, 44, all over 4. And we can simplify that down a little bit because we can write the 44 as a mixed radical. It's 4 times 11. So this would be 6 plus or minus 2 root 11 over 4. And every single term in that fraction can be divided by 2. So we are going to simplify that down. And it would be 3 plus or minus root 11 all over 2. Okay. So there you go. So that one does have 2 answers, and you want to leave it in the radical form. For part B, I'm not going to do that one fully, but I'll get you started. So so the first thing you'd want to do here is just move the 3 to the other side. So you'd have 1/2 x squared minus 5 over 4x minus 3 equals 0. However, you don't, and you could just apply the quadratic formula right now, but we really don't want to deal with fractions because the quadratic formula already has fractions in it. So you want to make your life easier and multiply everything here by 2, just to kind of cancel those fractions out. Actually, sorry, you'd want to choose 4, because then all the fractions would be canceled. So then you'd have 2x squared minus 5x minus 12 equals 0, and now it's way easier to apply the formula. Like I said, you would get the same answer, but it would be really challenging with fractions on fractions and would be pretty messy if you tried to apply it right away. So you want to multiply by a number to both sides of the equation that's going to cancel out those fractions. So you'd want to choose 4 here since 2 and 4 both divide into 4. And then you would want to apply it. So if you want to try that one, you can go ahead and you can check your answers down below there. Okay, and then finally, there's just a word problem which you could try. I'm going to leave that one out. So the key idea here is that all you do is just set up your equation so that it equals 0, get it into a nice format, and then you just plug in the numbers. If it can be simplified at the end and you can write a mixed radical, you do want to do that. But other than that, that's all we've got for this lesson.